MX feature software-defined WAN. So how do we go about implementing this? SD-WAN completely abstracts the transport away from the service, giving complete transport independence. We do this by using our AutoVPN functionality. As long as there is IP reachability, AutoVPN will build the IPsec overlay tunnels. Application optimization. As with all Meraki devices, application visibility is built right in. You can use this application awareness combined with QoS and traffic shaping and ensure super granular control over the traffic flows on your WAN. Meraki supports not only failover and load sharing, but granular intelligent path selection based on individual traffic flows and traffic types. You can set specific rules based on source address, destination address, port number, application type, or a combination of any of those things. As well as brute failover, when a link goes down, we also support soft failover of individual traffic types based on custom criteria. So what does this mean? Well, you can set up a custom performance class that says, for example, VoIP traffic should be on a path with less than 150 milliseconds of delay. The preferred link for this voice service may not fail completely, but due to congestion or upstream issues, have high latency. The MX device will monitor these thresholds and dynamically move the voice traffic over to a more suitable WAN connection. No waiting for users to call up and complain about voice quality, no manual intervention. So this is intelligent path control. From a security perspective, the overlay VPN isn't just providing a virtualized transport, but it's also a secure encrypted tunnel. This can give you the comfort that your private corporate data can traverse the public internet without any fear of compromise. MX feature highlight: failover and high availability. Mission-critical networks can't afford to be down. At Meraki, we've built multiple layers of redundancy into our MX product line to protect your networks against WAN failure, power interruption, and appliance faults. In the event of an appliance failure, the warm spare feature will ensure that your site stays online automatically. Because your configurations and features are synchronized from the cloud, all of your firewall rules, DHCP configuration and leases, VPNs, and advanced security services will continue to operate off the backup device. Virtual Router Redundancy Protocol, VRRP, ensures minimal interruption to client devices as the switchover happens. Dual redundant WAN connections means you have the option of protecting your network connectivity to the internet via multiple service providers. This can be achieved with a basic failover or using concurrent load balancing if required. Granular traffic control rules allow you to specify what traffic takes priority on each link and ensure that in a failover event, your most critical traffic continues to operate as expected. All MX devices also support cellular WAN, providing a third option to access the internet in the event of a total exchange outage or a backhoe event. High availability is simple to configure, and monitoring of links and devices is all directly from the dashboard. Alerts can be configured to notify the administrator of a failure event, so a ticket can be raised with your service provider or an RMA arranged for the device. Resource: MX Sizing Guide. This document is available on our website via the link at the bottom of the slide. Alternatively, just Google Meraki MX Sizing Guide. It's a fantastic resource for helping you with the question, which MX is the best fit for my network? The sizing guide provides a side-by-side comparison of each model of MX so you can select firstly the physical requirements such as port quantity and type, PoE, power, and so forth, and then compare line rate network performance. It goes on to articulate each security feature and the comparative performance impact of enabling that service. Most useful, though, are the real-world use cases. These cases have been developed in collaboration between product development, engineering, and the sales teams of real-world customer networks. Do you want to know what a K-12 school with limited bandwidth would look like? How will their device perform with NAT, content filtering, layer 7 firewall rules, traffic shaping, malware protection, safe search, and web caching all turned on? Well, it's in the sizing guide. How about a college that's a high bandwidth user but only wants to enable NAT, malware protection, and layer 7 to block BitTorrent? Well, that's in the sizing guide too. Retail services for branches or head offices, all in the sizing guide. So this is your go-to resource for comparing our products against each other and as a tool to use when comparing us to our competitors. We constantly revise and update it as we add new products and features to our security portfolio. In this video, we discussed the Mx platform, various models of Mx security appliance, licensing type and features, the cloud-brokered automatic site-to-site VPN, malware protection, software-defined WAN, high availability features, and how to choose the correct size of Mx for your requirements. This concludes the video on the Mx series of security appliances. I hope it's been informative.
Hi, my name's Joe, and in this video I'm going to show you how to give an effective Cisco Meraki Mx security appliance demo. All of this demoing will be done in the Cisco Meraki dashboard that you see before you, and in addition to some general demo tips, we're also going to cover 4 specific key feature areas that are important to include in demos. The first of those is next generation firewall functionality. The second is advanced threat capabilities. The third one that we'll talk about is VPN. And finally, software-defined WAN, or SD-WAN, as you may have heard it called. First of all, a lot of security customers look at the Mx as, before anything else, a firewall. So it's important to demonstrate that it has the core firewall functionality that they expect from a perimeter security device. This security appliance firewall page has most of that functionality contained in it. It's very easy to demonstrate how to add a new firewall rule at layer 3 simply by, say, creating a deny all rule and then creating a series of rules above it. And we can reorder them here with this little compass point icon. So if we want to allow ICMP traffic from a particular subnet to any destination or to a particular subnet and say allow ping from voice subnet, we can do that, right? We can demonstrate how easy it is to configure these rules in this dashboard. It's important to call out that while these can be configured on a network by network level at individual locations and on individual MXs, you can also configure this in a template format where you have one configuration shared across multiple MXs. So that makes it very, very easy to apply these firewall rules at scale. Now, while layer 3 firewalling is important, more and more the industry is moving towards application level firewalling, the layer 7 component. So that's where you really want to focus your time on this page. Down here in the layer 7 firewall section, you can again demonstrate how easy it is to create something like a rule blocking BitTorrent traffic, or even all peer-to-peer traffic. Another rule that is blocking sports-related traffic. Another rule that is blocking an individual HTTP hostname like hp.com. So again, it's important to focus on the simplicity, how easy it is to accomplish these functions. It's all GUI, it's all point and click. Now, this is probably the most straightforward functionality in the Mx because it is just firewall functionality. When we move past just perimeter firewalling and into the more advanced threat protection, that's where some of the really powerful Cisco technologies that we've implemented come into play. So moving away from this firewall page and to what we call the threat protection page. Threat protection in the Mx involves 2 major components: advanced malware protection, or AMP, and a snort-based intrusion detection and intrusion prevention engine. These are both very, very important to effective security, malware and IPS. The intrusion prevention and detection are also very, very important in the retail vertical because they are required for PCI compliance. So retail customers will have to have these in order to meet those compliance standards. The most powerful thing about demoing the AMP and the IPS components is that it's much, much simpler to configure and very easy to manage compared to a lot of other solutions out there. So the AMP configuration is literally a light switch. You turn AMP on, you are protected. You are protected against millions of known threats. You're protected by the Talos Cisco Security Intelligence and Threat Research team. You are protected by the entire breadth of Cisco Security's presence in the industry, all with that one click. And that's a really compelling story to tell when demoing this feature. Now, for those of you who may be worried that this isn't enough to demo for this, I will show you in just a moment how to demo the monitoring interface, which adds a lot of value there and has a lot of really cool demo flows that you can use to show how this can be used to make a network more secure. You can also whitelist individual URLs or files if you are doing internal testing or if there are things that maybe you believe are false positives. You have that ability here. For intrusion detection and prevention, it's a very similar story. You either enable detection or prevention. Prevention, of course, including blocking. And you select your rule set, connectivity being the most lax, balanced being somewhere in the middle, and security being the most restrictive rule set. And we define those rule sets and how they're generated in our documentation that's linked here on the page. Once you've configured these two features, again, these Cisco industry-leading technologies, you can go over to the Security Center page in order to monitor your threat posture. I recommend always demoing using the Organization Security Center link. This aggregates together this threat data from all of the locations rather than just looking at one. And so it will show you a bunch more data and allow you to look at this data broken down by which locations generated it, as well as a bunch of other information. So let's go through the Security Center page and look at what it can show us. First of all, we have our events over time, so we can see spikes, like this one right here at the end that we'll take a look at in a second. We can see which networks are most affected, networks in this case being locations. So San Francisco, London, and a little bit of Sydney there are the most prominent generators of these threat events. We can see which clients generate the most events. There's a big outlier here, this one device generating a lot of threat events may indicate something's wrong there that we may want to dive into. We can see the sources of these threats. What are the servers out there in the world that we're seeing these threats be coming from? We can also see which threats are most prevalent. So we have these threats that are generating a lot more events than any of the other threats that we've seen. Now you can manipulate this data in a variety of ways. You can look at this at a more specific time frame, dive down into an individual day, for instance, or even an individual 2-hour period. You can pivot this on a specific network to only see that location. You can go to a specific client and show only data for that client, only data for a particular threat source, or only data for a particular threat. You also have the ability to dive in deeper on any of those areas and see things like the summary report for that network, the client's page that we looked at earlier for that individual client, a who is lookup for the source to see exactly where these threats are coming from, or more information about a threat either through the snort signature or various documentation and threat publications that we'll link to there. All of this data can be viewed as well through the events page here, which shows the same data, but rather than summarizing it and aggregating it together, it shows the individual threat events or alerts in more of an event log style format. And you can actually, let's use this second client here, drill into that client and see their information, how they're connected to the network, right? What applications are using, the same data we saw before, and we can block them from the network or change their policy. This is another great way to show how easy it is to move from detecting a threat to preventing that threat from accessing or further infecting your network. This user will now be blocked from the network until they bring their computer in and you can image it, reformat it, clean it up, and then get it back onto the network. So that's another really compelling story to tell to those customers that are interested in the security capabilities. Now let's shift from the security component over to talking more about the connectivity side of the house. There are two major pieces there that we want to look at, and they're actually tied pretty closely together. The first is what we call Meraki Auto VPN, which is our site-to-site VPN that connects different branches or different locations in a customer's environment. And the second will be SD-WAN, which actually uses those VPN tunnels, those connections that are created to determine the best way to send traffic between locations.